All right, so my goal is to be able to get through 2 examples of you when we're looking at inequalities in the form of p of x divided by q of x. So a polynomial in the numerator and the denominator. So the first thing we have to understand, if we're dealing with a rational function, the denominator can't equal 0, okay? So when we find the solutions, the first step remains exactly the same. First, we have to identify the zeros of the function. So the zeros, the x-intercepts, are when the numerator equals 0. Okay, so I take my numerator, I set it equal to 0. We can disregard the inequality for right now because we're just finding the x-intercepts. GCF of x squared, that leaves me with x squared minus 4. X squared minus 4 is the difference of perfect squares. So I have 3 zeros. X is equal to 0, x is equal to 2, and x is equal to negative 2. All right, but now, because we have this rational function, we have a domain restriction. Okay, so we have to consider where the domain restriction exists. So to find the domain restriction, we set the denominator equal to 0. Okay, so setting the bottom equal to 0, x plus 1 equals 0. So x cannot equal negative 1. Okay, so that's a very important piece of the puzzle. And not only that, but we have to plot that domain restriction on our number line as well. Okay, so I'll write that on this slide before moving on. So I'm going to plot zeros and restrictions on the number line. So there's a lot of them, all right? Negative 2, negative 1, 0, and 2. All right, now let's look at our inequality. Our inequality is all values less than or equal to. So when I'm thinking about writing my answer, I know, change the highlighter. I know that I'm going to be using closed brackets because I can equal. But we have to be really careful that we're understanding, that you're understanding, even though I can equal negative 2, 0, and positive 2, because they're my x-intercepts, I can't equal negative 1 because it's my domain restriction. So if negative 1 is involved in an interval of my answer, I actually need to give it a soft bracket there. Okay, and the reason being is it's a restricted value. All right. So now let me go back to my factored form here. So this was x squared, x plus 2 times x minus 2 all over x plus 1. All right, now when I test my values, I got a lot of places that I have to actually plug in for. So I'm gonna pick negative 3, negative 1/2, negative half, positive 1, and positive 3. Okay, so when I plug these in, I'm going to be plugging those values into 1, 2, 3, 4 pieces. All right, 4 factors to determine if the final output is positive or negative. All right, so a negative 3 squared, that'll give me a positive. Negative 3 plus 2 is a negative. Negative 3 minus 2 is also a negative, divided by negative 3 plus 1 is a negative value. So this would become a positive times a positive divided by a negative. So all my values smaller than negative 2 are going to give me negative outputs. All right, negative 1/2 into my first factor, that'll be positive. Negative 1/2 plus 2 is positive. Negative 1/2 minus 2 is negative. Negative 1/2 plus 1 is negative. So that gives me a negative numerator divided by a negative denominator. So it makes my next interval positive. Negative half, that'll give me a positive times a negative, all divided by a positive. So where are these coming from? These are coming from just looking at the output, the sign of the output in these 4 different factors. Okay, that's why I'm keeping them in those parentheses. So I get a negative divided by a positive. It makes my next interval negative. Between 0 and 2, I picked x is equal to 1. So this would give me a positive, a negative, all divided by a positive. So that also gives me a negative divided by a positive, which would make that negative. And then lastly, at 3, that would give me a positive output. All of them will be positive. So my last interval will be positive. All right, now I got to go back to my original, right? So if I go back to my original, if I'm less than or equal to 0, I'm looking for negative intervals. And I'm thinking I'm going to be able to use my closed brackets on my zeros, but I need my open bracket if I include -1. Okay, so all my intervals where I'm negative, here's one of them, here's another one, here's another one. All right, so my conclusion, pay attention. So I can go from -infinity to -2, close bracket, soft bracket at -1, because that's a domain restriction, and then I can go all the way to 2 and end my interval with a hard bracket, and then it'll be the union of them. Why can I do that? Well, x equals 0 would be a closed circle. So I don't have to worry about breaking that interval up because I'm allowed to equal that number in there. And if you check that out, if I plug 0 into my original, I'm getting 0 in the numerator, I always do that, divided by 1, so that'll give me 0 as an answer. And I'm allowed to equal 0 because of my original inequality. So that is my final answer. All right, let me move on to another example. Find all solutions. Okay, so we start, first spot we start are the zeros, and we find the zeros by setting the numerator equal to 0. Take the square root of both sides, add 12, divide by 3, so n equals 4 is my 0. Sorry, guys. Next, I determine my domain restrictions. And domain restrictions come from where the denominator equals 0. I know that these look very similar, but they're not. For the numerator, the entire expression is being squared. In the denominator, just the n is being squared. So my initial steps are the same. But now I have to solve the equation n squared equals 4. So now when I take the square root of both sides, don't forget that n, you have to include both the positive and the negative. So my domain restrictions are that n cannot equal plus or minus 2. If we plug those numbers into the function, we would get a 0 in the denominator, and therefore it would be undefined. So now I take these 3 values and I put them on my number line. -2, +2, +4. Oh, I never changed this. I wanted to give you a different example. That should be greater than. Okay, so it doesn't include 0. So all of these, regardless of whether it's an x-intercept or a domain restriction, would be open circles, and therefore when I'm writing my intervals, they all get parentheses. They all get soft brackets. All right, so I'm going to look at this in factored form. All right, I promise you that that's the factored form. N plus 2 times n minus 2 gives me n squared minus 4. And then if I were to distribute the 3, I would end up with my original. My test values come from my number line, so I'm going to plug in. So the values I test in my original, I pick from the number line. So I'll test -3, between -2 and 2, 0, between 2 and 4, 3, and bigger than 4, I'll test 5. So now let's talk about the answers that you're always going to get. Let's see this. Okay, that doesn't want to come back. If you notice the numerator, if you plug any number in and square it, your numerator is always going to be positive. So I'll have a positive divided by -3 plus 2 is a negative number, -3 minus 2 is a negative. So that gives me a positive interval. If I plug in 0, again, my numerator is always positive. 0 plus 2 is a positive, 0 minus 2 is a negative. So that makes my entire interval negative. X is equal to 3, positive numerator, and both factors in the denominator are positive. And then lastly, 5, positive numerator, and same deal. Both factors in the denominator are positive. Okay, so now when I go back to my original inequality, I'm looking for greater than 0. So my answers have to be my positive intervals. And I have to exclude all zeros and restrictions because I cannot equal anything. So we'll only be using parentheses. All right, I don't know where my toolbar went here. So I can't highlight it. But positive intervals, I have a positive here, here, and here. I have to break it up at 4. Unlike the previous example, we didn't have to break it up. Okay, so my solution would be the intervals from -infinity to -2, from +2 to +4, and then from 4 to infinity. Okay, again, because I can't equal any of those values, I have to break them up every time I get a 0 or an domain restriction. All right, that's it. Thank you.